Okay, so you have a statics problem and you're wondering, where should I choose my pivot? So here's an example, and I'm going to try to apply the rule that I like, which is choose your pivot in a place where you can ignore some forces that you don't know but don't care about. So how do we apply that? Well, okay, so the setup is you have this beam of mass big M here. There's a mass little m hanging off of it. And then there's a rope that it's being held up by at a 45-degree angle, and it's attached to a wall. And the question, oh, and it's length L also. So the question is, what is the force of tension, the magnitude of the force of tension of the rope? Well, I like to start all of these problems just by writing out every force that we have on the diagram, basically a free body diagram for this object. So we have a tension force down from the rope of magnitude little mg. If this is a uniform rod, which let's say it is, there's a force of gravity acting down with magnitude big mg. There's a force of tension that's going up like this at 45 degrees. And then there's also forces from the wall, right? So there's an x component of the force on the wall. I'm not sure if it's left or right, but I'll draw it to the right. And then there's a force of tension in the y direction from the wall. Not sure if it's up or down, but we'll draw it up. So we don't know what these forces are, let's say, and we don't know what this force is, but we want to know what this force is, the magnitude of it. So where would you choose your pivot if you're trying to figure out the force of tension? Well, as I said, the rule is put your pivot in a place where there are things, some forces you don't know but don't care about. So where would that be? Well, that would be right here. So these forces, Fy and Fx, we don't know, but also we don't care about them. We're just looking for this. So the reason why this will help you is because when you're doing the sum of the torques, you remember that torque is equal to the magnitude of a force times r, which is the vector from wherever that force is to the pivot, so times sine of theta. And this r for, well, say for this would just be L, would be the r there. But for these, since the pivot is at the same point as the applied force, this r is just going to be 0. So they disappear from the torque equation. And then the sum of the torques is just going to be torque from big mg plus the torque from little mg plus the torque of force of tension. And so now we know these, and we know this, and we also know, since this is a statics problem, it's equal to 0, and then we don't need to worry about the sum of the y components of the force or the x components of the force. We can just solve this.